Statistics are like a bee swarm. Now, I'm not saying that statisticians should get stung for their projections and predictions about the future will hold based on past performance. But I am saying if you take a look at a collection of numbers, just numbers, and treat them as a bee swarm, you might be able to understand them. Let me show you what I mean. Here is a plot. It's called the bee swarm location plot, and on the right you'll see a number of red dots. These represent the bees. Their location on this chart is represented by an average value for the individual bee location and a variance, the spread amongst the bees. Now what I'm going to do is I'm going to start a macro that changes the average and not the variance over a number of trials, and we'll see what happens. You see this pink box? I hope you see the pink box. I'm going to click on it and start the process. And there we go. 250 for the average. It changes to 500. It changes to 750. And you can see as the average increases, the bee swarm moves to the right. Now, isn't that cool? Now, what if I decide to change the variance? Let me stop this process and go to the variance. That's the gray box. Now you see what happens when the average is 200 and the variance goes from 25 to 100. The bee swarm expands. Okay, that's a warm day. And the higher the variance, the greater the expansion. Now this is all cool, but it's still a big jumble of locations. Can we take a different look at this? Suppose these were numbers and we had these numbers all over the place. What could we really determine from them? So I'm going to go to another way of representing these. But I've got to stop this first. Now let's take a look where the bees are aligned in accordance with their location from the queen. So we sort them according to how far away they are from closest to the furthest. And let's take a look and see what happens if we change the average to this sorted collection of bees. And that would be the green line, the green curve. See, as we change the average, the green curve moves to the right. Now the variance is very small, so these red unsorted bees are staying fairly close to the green line. But if the variance changes, then that will not be the case. So let me stop this and see what happens when the variance changes. Okay, now let's change the variance. And watch the green line as the variance goes from 25 to 100 to 225, and I'm keeping the average constant. As the spread increases, the green line rotates around the center. And that's the advantage of treating a number system in this way. So thank you for watching, and have a great day.